Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAZMILADLI bin HUMAIDI. Today I would like to present about my final year project proposal presentation, which is design of the semi-interface motorcycle simulator, which is SIMS, counter steering, handlebar, mountings and assembly. My supervisor is Dr. HELMI bin RASHID. There are 6 content in this presentation. First, the introduction. Second is the literature review. Third is the problem statement and objective. Fourth is the scope and limitation. Fifth is the methodology. And the last one is the expected result. First one is the introduction. Why I perform this project is due to the increasing popularity of the motorcycles in recent years is mostly attributable to the global increase in automotive ownership. Motorcyclists are exposed to the environment and more vulnerable than other road users, affect their safety and their effort required to operate their motorcycle. Motorcycles were excluded from the benefit of the technological advancement. Motorcycle simulators have been constructed to research the rider-machine interaction. Researchers from University Teknologi Mara in Shah Alam, Malaysia are studying motorbike ergonomics. This research considers motorcyclists and pilots. Semi-interface motorcycle simulators was built. The simulators are portable and ergonomic. Most motorbike simulator doesn't implement the counter steering principle, a cornering physics law, single track vehicle like bicycle and motorcycle, which is its need counter steering to start each turn, which is steer left to turn right. To correctly traverse a turn, the rider must tilt the combined center of mass of the rider and single track vehicle in the turn's direction. The semi-interface motorcycle simulators comply with the counter steering physics law. The SIMS handlebar move and rotate in the Z direction. This design lacked realism. This paper describes the design and manufacture of counter steering handlebar mount. The plan will align the handlebar Y-axis rotation with the motorcycle riding. Based on the research, there are 4 literature reviews, which is physics law of counter steering, ergonomic, handlings and stability, and lastly is the material. The first one is the physics law of counter steering. The concept of counter steering is contradictory, since turning the wheel to the right would be consequence of pushing the left and pulling the right when the front wheel is not spinning, and turning the wheel to the left would be the result of pushing to the right and pulling to the left. The concept is simple, which is when we want to turn the motorcycle to the right, we need to push the handlebar to the left, so it will turn to the right. The vehicle experiences both centrifugal force and front tire lateral force, causing it to lean into the turn and vice versa. This is the figure how the concept of counter steering will apply to the motorcycle. Next is ergonomic. Ergonomic is the study of human-machine interaction and the implement that influence the relationship. Its objective is to enhance system performance by enhancing human-machine interaction. The height, posture, and size of the individual may cause discomfort. This will cause motorcycle to experience muscle fatigue and accident. To provide customer with comfort, handlebar design, and mounting, it must prioritize the ergonomic element. Next is about handling and stability. Handling and stability is referred to the ability of a vehicle to maintain control and stability under different driving conditions. Stability of a vehicle handling is one of the most critical performance characteristic influencing the active safety of vehicle. A rider gripping the handlebars passively affect mass, stiffness, damping, and it could affect a wobble mode stability. Lastly, literature review about material. Steel is a commonly used material for handlebar due to its low cost, strength, and fatigue properties. Steel handlebar mounting may flex under pressure without collapsing, making them a popular choice. Different materials may be better for different types of motorcycle when it comes to handlebar mounting. Next is about the problem statement. There are two problem statements have been identified, which is the first one. None of the existing motorcycle simulators can perfectly illustrate the concept of counter steering, which is there are no design that can perform the concept of counter steering. And the second one is the old design of the counter steering handlebar mounting rotate in the Z direction. Next is objective. There are three objectives that used to countermeasure the problem statement. The first one is to determine the parameters for the handlebar of the counter steering handlebar mounting. Next, to design the new mounting for the counter steering handlebar. And lastly, to validate the counter steering handlebar mounting by using the computer-aided design simulator. The scope of my project is focus on designing the mounting for the counter steering handlebar for the semi-interface motorcycle simulator, which is SIMS. The design will employ the Yamaha R15 as the benchmark. My project limitation is the design of the mounting will only use for the semi-interface motorcycle simulator. The challenging is to replicate the condition under which the handlebar is controlled under the laboratory setting. Next is methodology. There are four phases totally in the methodology. The first one is the initial study. In the initial study, there are information gathering and product design specification. Information gathering is the process of collecting and analysis data or information to help to solve the problem. There are several information gathering that has been used, which is the first one is questionnaire, which is undertaken to gather the information of user needed. The second one is the literature review. Most of the data was collected during the literature review. And the last one is the observation. The Yamaha R50 motorcycle has been used as a standard observation. This is to understand the mechanism and component that has been used in the motorcycle. Next is about product design specification. There are four criteria that has been used, which is the physical detail, functionality, manufacture, and life cycle target. Physical detail, material being used is mainly mild steel. Height and size of the mounting will be based on the standard Yamaha R50 motorcycle. The mounting can easily assemble and deassemble for part displacement purpose. The mounting can be adjustable to comply with the ergonomic concept. For the functionality criteria, the handlebar can rotate in a Y direction, which is it can give a feel near to actual riding style. Next is by implementing actual feel during maneuvering and cornering. The last one is the handlebar can comply with the physics of counterlock. This is the most important part. Next is the manufacture. The manufacturer will mainly use cutting, grinding, and welding process. It will use bolt, nut, joint to mount it on the chassis of the simulator, which is on the aluminum profile. The life cycle target, the expected lifespan is more than 10 years if the user uses it every day. Next is morphological chart. There are four functions that use to generate the morphological chart, which is material, shape, adjustable, and type of joint. There are three solutions totally. For the material, there are three solutions, which is mild steel, plastic, and aluminium. For the shape, we consider the triangle, trapezoid, and triangle. And for the adjustable, it can be considered that either the design can be adjustable or cannot be adjustable. And lastly, for the type of joint, there are two types of joint, which is welding, bolt, and nut. After the morphological chart has been generated, here are the three concepts that successfully been generated, which is the first one, the second one, and the third one. Next is the path chart. There are 8 criteria used to evaluate each concept. It's important to evaluate each of based on this criteria to ensure the best design to the project. Finally, the expected result. This is the expected result that has been designed by using the criteria. As we can see, the design was used at Y15, Yamaha Y15 as a benchmark. It used a crown handle and under bracket of the Yamaha R15. The slider is used on the aluminum profile for the adjustable purpose. The potentiometer used to connect with the Leobotna board to give the interaction to the simulator. The force sensing resistor plate used to detect the sensor on how much force will apply to make it turn to the right or to make it turn to the left. That's all for me. Thank you for watching. Assalamualaikum.